My voice is clear now. Hey, I have been building this super intelligent dependency manager. This super intelligent dependency manager should help you resolve dependency conflicts. You might be familiar with the age-old dependency problem. If you're working with a huge JavaScript project, you've probably been bugged by those peer dependency warnings. For the most part, often find yourself stuck on legacy. Your eventual resolution would be, hey, I want to use my legacy peer dependencies, and that would be it, right? And that's just the start of the problem. If you're working with less opinionated libraries, it's often the case that some support for that dependency falls off the wagon, and then you are essentially kind of forced to either find another library that fills that position or continue with less support from the community given that it has been deprecated. So there's a lot of problems to this, and it's not just JavaScript. The tool that I've been building is essentially a dependency manager that helps you patch up heuristics provision. You can see I'm also using anti-gravity, which is like a Google tool that is basically providing you that ultimate project building perspective. But this, you can consider this application as our software that I just built as a smaller version of anti-gravity. It's very condensed and it allows you to manage dependencies. It's super intelligent in that sense to some degree. I have a few demos set up. For example, if you are trying to, let's say, upgrade basic dependencies, it does have a CLI, which you can interact with. So the target audience here is usually a developer. Then if you want to, essentially go ahead and use the CLI to update your dependencies, you'd call the configure command. You'll configure it to the specific package manager, which is pip in this case, and your path to your sample Python project. And then once you do that, you pass the project name, and then there you go. Once you configure that, you run the dependency scan on your Python project. It looks up the basic dependencies, and what it does is just look up the requirements. Well, if it's the JavaScript file, just look up the package.json, then it will do the intelligent update, where you can run the update command with auto approve. If you've been using LLM tools like Cursor, you have this auto approve flag, and once you toggle that flag, it will allow you to let the LLM make its own decision of updates. And then you'll see this execution update. Of course, this is vibe coded, and you'll see a lot of emojis and updating project, sample Python project. It will do that. It will lock that out just for your visibility. The risk summary would be something like total updates to determine the risk and overall risk. It will see how less risky it is depending on the dependency complexity. Once it does that, this is pretty straightforward, and this might actually be an existing tool. Where this tool comes in handy is when you have a large set of dependency requirements. Here is the one that analyzes the change logs and code usage to determine risk rather than solely relying on semantic versioning. I want to do this, but I'm not sure I've set up correctly, but I'll get back to you with more of the setup and details. But yeah, this is what I have built. I also have a JavaScript demo set up. Let's say you have a React 18 application that is trying to update a legacy UI library called Fancy Grid, strictly requires React 16. Then you package JSON. You have your dependencies with a minimal of 18.2.0 and a fancy grid of, and then in your fancy grid package.json requires at least 16 and above. So when you run the scan on your dashboard app, it will say peer dependency conflict detected. Package fancy.grid.o requires React 16 and found only React 18.20. This conflict prevents standard installation, and you have to resolve it. It'll give you a couple of options. So npm does this to some degree. So it could be like, hey, use legacy peer deps and risky runtime errors likely, and downgrade, and you have to downgrade React to 16.14.0, or rewrite. It means essentially replace Fancy Grid with a modern alternative. The intelligent rewrite solution is, instead of forcing a broken state or holding the entire app, we choose a rewrite strategy. The agent identifies the Fancy Grid is used only for a simple data table and replaces it with a modern zero dependency implementation. You could pass a resolve strategy rewrite, target Fancy Grid, and you can pass targets with that option. So it will initiate a rewrite strategy for a fancy grid and analyzing usage of the component. It identifies the usage on what possible rendering or basic column is used, and no complex features are used. So generating a replacement component on its own, implementing the accessible table structure, and verifying compatibility with React 18 and applying code patches accordingly. So the code patches in this case are modifications for the package.json, removing the fancy grid, and new source components UI, modern grid.js, and modifying the app.js, essentially switching up the imports. As you can see in this nice diff, you removed that dependency and replaced it with its own custom local solution. So this comes with an extra cost of maintenance because this has to be documented somewhere. Essentially, you're making your own decision of creating components, but it all comes down to how you want to guide the patching tool. Let's see another example. So I have, for example, a massive framework upgrade. So for example, you might have essentially an initial state, a legacy microservice running Spring Boot 2.7 extensively used in the servlet API. It looks up the POM file, similar to how it should for Python. It would look up the requirement.txt, or for JavaScript, it will look up the package.json file. Your current Spring Boot version is 2.7, and then it will upgrade that. Let's say your demo controller, you have your REST control here and your mapping or whatever it is, and you can run a deep scan and migration detection. So it detects Spring Boot is available, and it gives you that breaking flag, and it will generate an update plan, major framework upgrade detected, Spring Boot X, info analysis, or whatever. It gives you that additional set of information, and it will spit out, hey, this is a risky migration, and we can just do an automated migration with this. Think of this as, again, not a complete solution yet. You can run the update project, pass that project, and migrate with an auto approve flag. And once that happens, you can see the patches. You will have that version change for the specific dependency in the POM file, and then you have the source code refactoring. You have the JavaX being replaced with Jakarta, which is the corresponding library that is compatible with that specific Spring Boot version. The patch is applied to old Java files. This is an interesting example. Let's see another demo where you're like, okay, you have dependency graph. For example, you have a mono repo setup with two internal packages. You have package auth and package core. They're currently at, let's say, version .0. Use of package auth package auth 2 requires package core and vice versa. So it creates this kind of lockstep upgrade requirement. A package version .10 requires package core v1.0, so B requires A, and also A requires B. This is a circular scenario. And package auth version of dependencies is super package core, and you can see that it's also 1.0.0. So it has a cycle detection. So essentially, you have bin, superint dep manager, scan. So this is just, you can consider this as the binary. Eventually, once it's shipped to production, you'll see it in a nicely formatted CLI. You could call it SDM or whatever. And then workspace packages. And then the scan output would be, you'd get that notice of warning, which is like you have a circular dependency, or essentially the locked dependency. And then you have the available updates listed. And it will generate an update plan. The info is linked version strategy. And you also have an atomic group update. So the agent groups updates in a single atomic pull request. Updating them individually would cause the build to fail. Dependence would be unsatisfiable during the transitional state. And the command would be something like update workspace, pass the packages folder, and then strategy atomic. Once you do that, you have this atomic group update. You verify build consistency, and then create a pull request. So there's an applicator that is also kind of integrated. So with this application, so essentially it's kind of nicely fitting with your GitHub project. So that's also the goal here, to kind of have this possible bot that you can run on a recurring basis that allows you to possibly run the scan operation that you saw earlier. And if it sees any possible patches that needs to be made, it will run the update agent on a need basis. I've also considered dependencies where you cannot move any further. Essentially, let's say you have a Python service that has drifted from its requirement txt and you use this request without declaring it and relies on an abandoned library like simplepad for string padding, which has a security flag. And let's say your source it imports requests from simplepad import pad left, and you define fetch data function which requests and use the get method to call this, and you have your defined format ID and you pass in your ID and you return pad left, you pass in the string of ID 5 and 0. So this is your source doc, and you have your requirements, which is like you need Flask 2.3.0, you have simplepad 1.0.0, and request is missing. The scanner performs a static analysis on the source code to validate imports against the manifest. You can do a deep scan, and the scan output should be able to go through any possible anomalies and find whole dependencies. So in this case, request is imported in source by but missing this basic static analysis. You get this out of the box with linting tools or any static analysis tools, and then you'll also see that you have the vulnerability indicated for the simplepad, which is abandoned and has one critical vulnerability, no safe version available. And the recommendation is like, hey, you're gonna go ahead, add requests, standard fix, remove simplepad, and replace it with a native tooling, which is a zero dependency fix. It intelligently cleans up tooling based on availability. If it's spaghetti implementation where you're overfetching dependencies and not utilizing local or standard libraries, it can also do that zero dependency fix. And eventually, you can do that intelligent patching. You have this heal flag to fill holes and apply custom patches. And again, you can also pass the auto approve flag. Once you do that, it's essentially healing the project. You fix whole dependencies, identified request version, whatever it is, from 2.3.1.0, and it generates a zero dependency patch. It can be replaced with Python string zfill or f strings. It generates a native implementation. It applies code patches to two files, one to the source file and one to the requirements file. 2 issues resolved. And comprehensive diffs of this repair would fill the hole and remove the problem library, essentially. So simplepad was essentially in problematic or vulnerable library. It will fill that position, and you have the zero dependency code patch source, and it also patches the source files as well. For now, the 3 main languages are Python, Java, and JavaScript, but it would be interesting to see how this could expand. And to reiterate, it's mostly going to be a specialized tool, though it feels generalized to multiple languages because the heuristic provision is essentially, it allows you to patch up dependencies based on LLM responses, right? So I want to see how best I can push this to production and see your perspective. The initial MVP that you're probably going to see is just a simple drag and drop project where you drop your project in on an upload box. You would essentially be able to get a patched up version of your project. So that would be the kind of eventual shot that we're going for. Okay, so that's pretty much it. I hope you enjoyed this little vibe coded application. It's partly the age-old logistics problem of having to identify the specific dependencies or resources missing in my project. How can I make sure my project is continuously rolling and is up to date with any fixes, any patches? How can I essentially migrate my project if there is no long-term support for any core dependency and other problems that come in and that kind of take away your time as a developer, your precious time? So that essentially this is a problem I've noticed is worthy enough for an LLM to resolve and essentially act as a provider. I will come out with more, but this is what I have so far.